coming to the next problem, this will be the last problem in this particular chapter, and I guess this will be the last video for this chapter. The fuel cost in dollar per hour of three thermal plants are C1, C2, C3. So here we are having three thermal units. This is C1, C2, C3 values. This is the P loss expression. So the loss coefficients are specified in per unit on 100 MVA base. So these loss coefficients are specified in per unit on 100 MVA base. So for power demand 150 megawatt, find the optimal dispatch of generation. So since we are using 3 units, so these are the expressions. So whatever expression we had used earlier, this is in the expanded form, this will be the expressions we will be using. This is the P loss expression, dPg1 of R d lambda, dPg2 of R d lambda, dPg3 of d lambda. This is the expression. This is nothing but whatever equations we have seen, the summation, I have expanded it for 3 generating units. So these are the resulting expressions we will get. And this is delta P of R expression and delta lambda of R expression. So here first thing is the loss coefficients are in the per unit value. Now they are to be converted into the actual values. So here there is a small trick. Now in order to normally for voltage, power, current, impedance, if we have to convert it into the actual values, we multiply it with the base value. But here for the loss coefficients, to convert it into actual values, we have to divide it by the base value. The reason is the unit of loss coefficient is per megawatt. The unit for loss coefficients are per megawatt. So the base value for loss coefficient will be 1 divided by 100 MVA. It is not 100 MVA, it will be 1 divided by 100 MVA. So when you multiply this value into 1 divided by 100, so this is the expression you get. You have to divide it by the 100. Clear? So now whatever the resulting coefficients are there, they are your loss coefficient. So here you can see that you have only the square term. You don't have Pg1 into Pg2, Pg2 into Pg3, Pg3 into Pg1. So which means that these coefficients are 0. B12, B31, B23. That is the off diagonal elements are 0. Only we have diagonal elements. So these terms are 0. So the next one is initial estimate. So now here we have assumed the initial estimate to be 100. Now how did I get that value? I have chosen we have chosen a value nearer to this B value. Fine. So initial estimate of lambda. So from this initial estimate of lambda, first we have to calculate. Now using this initial estimate of lambda, you don't have to calculate Pg1 of 0. Now why it is not required here? Because I'll just go back to this expression here. We know that B12, B31 and B23 are 0. These off diagonal elements are 0. Coming to this expression here, you can see that this term, now because of this term we were calculating the 0th iteration power output value. Now even if we calculate the 0th iteration power output value, when we substitute the values, since this is 0, this is 0, this second term will become 0. This gets eliminated. So that is the reason why we are not calculating the 0th iteration value. Similarly here, see B21, B23, B21 and B23 is 0. So this second term will be eliminated. Even here, the second term will be eliminated. So that is not required. So that is the reason why 0th iteration calculation is not done. Similarly here, so these values are eliminated. So these values are eliminated because they consist of product of off diagonal elements which are 0. So the resultant of this term, the resultant of this term will be 0. So this entire third term is eliminated, so which is not required. So that is the reason why we are not calculating Pg1 of 0. The 0th iteration power output is not calculated. Clear? So we will straight away start with Pg1 of 1, that is the first iteration. So I have seen in the previous expression that I have shown, when you substitute the value there, this is the expression you get. I'll once again show the expression that I've used. So this is the expression I have used. Lambda minus b1 divided by 2c1 plus lambda r b11. This term is eliminated. So lambda minus b1 divided by 2c1 plus lambda 1 b11. So I get 51.31 megawatt. Similarly, Pg2 of 1 I get 78.53 megawatt. Next I calculate Pg3 of 1, which I get 71.16 megawatt. So correspondingly I'll calculate delta P loss of 1. So you have only the diagonal elements. So Pg1 square, Pg2 square, Pg3 square, when I substitute, I get delta P loss is sorry, not delta P loss, this is only P loss. So this is not there. So delta P P loss is equal to 2.886 megawatt. So corresponding, I'll calculate delta P of 1. Okay, the expressions have already discussed. The similar expression PD plus P loss minus summation of Pg1 of 1. Okay, next I'll calculate dPg1 by d lambda, which is nothing but lambda 1 plus b1, not lambda 1. This is b1 plus I'll go back to the expression here. Yeah, this one, c1 plus b1 b11 divided by 2c1 plus lambda of r b11 square. Okay, so this term is eliminated here. So using that, I'll be calculating dPg1 of 1 by d lambda. So I get around these values. So when I substitute, I get delta lambda is equal to minus 0.3155. So next I'll update the lambda value. I get around 7.6845. Again I'll calculate Pg1, Pg2, Pg3 of 2. This is the second iteration. So the three values are calculated and I get the corresponding values here. So final substituting in P loss expression, I get P loss expression here and I calculate delta P of 2. So for more accuracy we can go for next iteration also, but since we have got a 0.833, we will stop till here because it is approximately equal to 0. So then whatever these values we've got, we will take it as final, and this is the final result. Pg1, Pg2, Pg3 will be equal to these values. So this is the procedure of solving this question. Thank you.